Okay, this is Algebra 1, Section 1-4. We're doing mental math to determine if equations and inequalities are true. We're checking solutions of them. Begins on the text on page 24. Handful of definitions to start. An equation, basically the most important part of an equation is there's a left side, there's an equals, and then there's a right side. The equals is what makes it an equation. There's something on the left and something on the right. A solution of an equation is when a variable is replaced with a value. The important part about a solution is it makes a true statement. If when you plug something in, for example, as simple as can be, x plus 1 equals 3. We know that that value, to make it a solution or a true statement, x has to be 2. If you plug in the number 3, it's not a solution because 3 plus 1 would not be equal to 3. So a solution is makes a true statement. An inequality is just like an equation. There's a left side and a right side, but instead of having an equal sign, there is an inequality sign. Now, sometimes inequality signs have or equal to connected to them, but it's not just a straight equal sign. That's greater than or equal to, less than or equal to. You guys know that there's also less than and greater than as well. We'll talk more about that when we get to another section. But an inequality has a left side and a right side, just like an equation, without an equal sign in the middle. It has an inequality sign. And then just like the solution of an equation, a solution of an inequality is going to make it a true statement. X plus 1 is greater than 3. Now, all I did was notice I just changed the equal sign to an inequality, greater than. It has to be the number 3, or it has to be something that's larger than 2. Because the number 2, when you plug it in, is going to give you 3 is greater than 3, which is not a true statement. It has to be something greater than the number 2. The first example is substituting to check possible solutions. It says check whether the numbers 1, 2, and 3 are solutions of the equation 2x plus 3 is equal to 5. Now, anytime you have situations like this where you plug in something in and it's going to be equal to something else, it is impossible for all three of those values to be solutions. It's impossible. So once you find the solution, you know the other two are not going to be solutions. So for example, we're plugging in the first number is 1. 2 times 1 plus 3 is equal to 5. 2 times 1 is 3. 2 times 1 is 2 plus 3 is going to be 5. Notice the statement 5 equals 5. Just like the bell work we did when we made a true statement or a false statement, this one's true, therefore it is a solution. When you plug in the number 2, 2 times 2 is 4 plus 3. You know that that's the number 7. That is not a solution. 7 is not equal to 5. And likewise, when you plug in the number 3, 2 times 3 is 6 plus 3 is 9, which is not equal to 5. That one is not a solution either. So again, once we found that first one was a solution, it was impossible for the second two, or numbers 2 and 3, to be solutions. Copy down this example. Take about a minute to work this one. Okay, we're checking whether 3 and 4 are solutions to the equation 5x minus 7 equals 8. Well, we know enough about order of operations that we have to do our multiplication first. We'll plug in this first value, 3. 5 times 3 minus 7 equals 8. 5 times 3, we know to do the multiplication first, is 15 minus 7 equals 8. Then when you subtract 15 minus 7, you get 8 equals 8. That's a true statement based on what we said a minute ago. So yes, this one is a solution. Based on what we said a minute ago, once we have a solution to an equation like this, it's impossible for the other one to be the solution. But let's go ahead and plug it in just to make sure. When you plug in the number 4, 5 times 4 minus 7 equals 8. 5 times 4 we know is 20 minus 7 equals 8, and 20 minus 7 is 13. Notice that is not a true statement, therefore it is not a solution. Now when we get to inequalities in a minute, you can have more than one solution to it because it's going to count all the numbers that are either greater than or less than, so you can. But when we're talking about just equations like this, it can only be one number. Here's example number 2. Using mental math to solve a real-life equation. It says a box of pencils costs $3.08. A package of pens costs $3.45, and a notebook costs $2.79. You have $8. About how much money do you have, or how much money do you need? So what we're doing is we're just going to estimate using these values. We're going to round them either up or down to see how much money we actually need. So you can ask yourself the question: the total cost equals 8 plus what amount? I'm sorry, 8 plus what number of dollars? Let X represent any additional money you may need. Use rounding to estimate the total cost. So we have 3. Now notice the first box of pencils was $3.08. We represent that with the number 3. Okay, that's just rounding. We rounded down 8 cents. We're calling it about $3. $3.45. We're saying that's approximately 3.5 or 3.5. Plus another 3. Notice we rounded up for this next one. The notebook's $2.79, so we went up for that one. So we went down a little bit on 308. We went up a little bit on 279, and then it equals 8 plus X. So we're using numbers that are easier to manipulate. 3 plus 3.5 is 6.5 plus 3 is going to be 9.5 is equal to 8. So what it's saying is 9.5 or $9.50 equal to 8 plus what number? That's what this always represents, a variable. What number? So 8 plus what number? You know that at 1.5 or $1.50 is going to get you to the number 9.5 or $9.50. Says the total cost of supplies is approximately 9.5 or $9.50, so you need about $1.50 more. Okay, I'm going to jump ahead 2 slides because it matches a little bit better. Work on this problem. Again, you don't have to copy down the whole problem. Just copy the values and then estimate based on that $20 bill to see how much change you're going to need. Take about a minute to do that one. Okay, went a little bit longer than a minute there. Again, you don't want to copy all of this down, so we'll just take the values that we need. It says cheese costs $5.99. Let's say that's $6 for cheese. Pizza dough costs $2.39. Let's call that 2.5 or $2.50. So 6 plus 2.50. Another thing, tomato sauce, that's $2.49. That's really close to 2.5 or 2.50. So let's call that another 2.5. And then it says pepperoni costs $2.98. That's really close to $3. So let's call that 3. So those are just estimates of those 4 values for each of those ingredients to make the pizza. So when we put all of that together, and we're going to get to the rest of the problem in just a second, but when we put all of this together, 6 plus, now 2.5 and 2.5 might be a little tough for you, but you know 250 and 250 is $5. So these two together make 5. And then that plus 6 is 11, and 11 plus 3 is going to be, all of that together is going to be approximately $14. So now let's go with the rest of the problem. It says you have a $20 bill. About how much change will you receive? Well, you know that if it costs you $14, everybody in here is smart enough to understand that you're going to take away $14 from that $20. So 20 minus 14 equals the value we're actually going to get, or the change you're going to receive. So 20 minus 14, we know that we're going to get approximately $6 change based on what we had, or based on the ingredients cost. Now I got to go back a little bit. This is the one. It says decide whether 3, and this is on you guys' sheet, decide whether 3 is a solution of the inequality. And they give us 3 different inequalities, but we're using the same value. So x plus 3, you're just substituting in the value. 3 plus 5, I said x plus 3, I meant x plus 5. 3 plus 5 is less than 9. Now you're looking at this and you're determining its truth value. If you ever see that phrase, truth value, that is a true statement. 8 is less than 9. A lot of people get this symbol and this symbol confused. Which one is which? You can kind of tilt your head a little bit and see this one. It says less than. You can write the word less than. Or another way to remember it is the smaller end, or the point, points to the smaller one. The way I learned it is the big mouth, we learned it as alligator mouth. The big mouth eats the bigger number because it's hungry. So this is the bigger number over here, and this is the small number over here. So just in case you get those signs confused, it says 8 is less than 9. That is a solution. The next one says 3x plus 2 is less than or equal to 11. When you plug in the number 3, you get 9 plus 2. And 9 plus 2 is 11. So now we have this truth value we have to check. Is 11 less than or equal to 11? Well, it's not less than it, but it is equal to it. Therefore, that is a true statement. Just like A was, so is B. And in C, x minus 1 is greater than 4. When you plug in 3, you're going to get the number 2. 3 minus 1 is 2 is greater than 4. That is not a true statement. Unlike A and B, C was not a true statement. Therefore, it's not a solution. Okay? Copy down this problem. Take about 30 about 1 minute, because there's 3 different problems. We'll come back in a minute. Okay, let's take a look at this one. I know there's one little multiplication step that might be slowing you guys down in this one, but it's not a huge issue with the problem. So let's take a look at each one of these numbers. We're taking a step back a little bit to look at equations again. This says 12s. Notice that they're in this problem, they're using s's in conjunctions with 5s. So make sure you are writing neatly to differentiate those two, or just make it say x instead of s. That'll be something that'll come up on tests, and especially standardized tests, a lot, just to kind of trick you up. They use S's and 5s a lot, and they use B's and the number 6 a lot because they look very similar. So 12 times 5 plus 5 is equal to 125. We know that 12 times 5, if you think about inches in a ruler or how tall you are, you know that that's 60 inches. Plus 5 is 65, is not equal to 125. So no, that is not a solution. When we do 10, this one comes out a little bit neater. 12 times 10 plus 5 equals 125. 12 times 10 is 120. All you got to do is add a 0 to it. Plus 5 equals 125. That one is true. 125 is equal to 125. So that one is the solution. Again, what we said earlier, when you're talking about equal signs or equations, once you have the solution, the other ones can't be true. But just for argument's sake, we'll check 15. 12 times 15 plus 5 equals 125. We knew that 12 times 10 was 120, and then 5 times 12 is 60, so 120 and 60 is 180, plus 5 equals 125. Notice that gives us the number 185, which we said a minute ago is not a solution. So no, only 10 is the solution. Okay, here's your checkpoint problems. We're determining if we're checking whether the given number is a solution of the equation or inequality. This question was asked earlier, what number? Notice how the problem's written. It says 4D plus 1 is equal to 9, and then there's a semicolon, and then it says 2. That's saying use the number 2. So if you ever see anything like that, notice it's not really part of the problem. It kind of looks funny. You don't know what to do with that semicolon. There's a reason. So 4 times D, 4 times 2 plus 1 equals 9. We know 4 times 2 is 8. Plus 1 equals 9. That is a true statement. 9 equals 9. So yes, it is a solution. Its truth value at this point tells you that it is a solution. Number 2 says 5n minus 7 is less than 23, using the number 6. So 5 times 6 minus 7 is less than 23. You know 5 times 6 is the number 30 minus 7 is less than 23. 30 minus 7 is 23. So now 23 is less than 23. Here's a spot where some people might have made a mistake. You did all of that work and you got all of that correct up to this point. 32 is the correct simplified left side, 23. But notice this is not a true statement. Had it said 23 is less than or equal to 23, had it had an equal sign at the bottom, then it would be a true statement. But since it's lacking that or equal to spot, it is not a solution. That is a false statement. Explain what that is. Okay, if the question was asked, what happens if there's an equal sign with a slash in it? So 2 equals 4. This is not a true statement right here. But if you ever see a symbol that looks like this, now all this means is 2 is not equal to 4. That is a true statement. Okay, you're never going to use that as part of an equation. Most of the time when you look at it, it's shown just to represent something that's not true. So the last one we had to do, x squared plus 6 is greater than or equal to 55 when x's value 7. 7 squared plus 6 greater than or equal to 55. 7 squared is 49 plus 6. Greater than or equal to 55. 49 plus 6 is 55. So here's the same problem as 2. You did all of the work the right way. 55 is the correct simplified version. It's not greater than 55, but since it has that or equal to sign at the bottom, it makes it into a true statement. Therefore, it is a solution.